So this talk will, like we talked about MLX, but here we'll be talking about a specific library which is called MLX-Audio. So it lets you run TTS, STT, STS and many models, and it is specially baked for audio, which is very interesting. Like my personal thing is that I like interacting with AI through voice. I don't like the chat interface. So that's the reason I wanted to use MLX-Audio a lot. So this whole talk will be around MLX-Audio, a 101 about MLX-Audio. So what is MLX-Audio? It's a library built by Prince Kanuma. So this is open source made by a developer, which is very cool as the MLX community is growing. This lets you do many more stuff around audio, which is TTS, STT, VAD and many more stuff. This is built for Apple Silicon and this majorly runs on your GPU. Now what it does, so TTS was the first thing I mentioned, STT, STS. Now STS is something like, imagine you have very noisy input voice coming in and you get a clean audio out there. So this is one example of STS. VAD is basically diarization, like imagine 2 or 3 people are speaking here and it would figure out, okay, this is speaker 1, this is speaker 2, this is speaker 3 across our communication. And one very nice thing is voice cloning. So voice cloning is like, imagine I give my voice as an input to the model and it can on demand, like I just give it some text and I say generate and it can clone my voice on the go. Now all of this is first party and made by this package itself, so you don't have to probably code anything, just load the model and click generate and it would probably do that. So you can try it with one line. I elaborate with the line. So it is just import MLX-Audio, MLX-Audio.tts generate, select the model which you want to. For here I am using Kokoro, which is just 82 million parameters. This is approx 300 MB only, and this works like a charm. And whatever text you want to. So Kokoro come with like 54 set of voices. You can just select the voice you want to and like hyphen play, and the moment you run this, it will load the model in memory first and then probably it will run the model to converting text into speech. Now this is a Python package basically, so you can write Python code with it, which you guys are mostly familiar with. You can just import mlxaudio.tts.utils, and from that, so the thing I was telling, it's so simple that model equals to load model, whatever model you want to, and you have to get the model from MLX community. So this is not some random model out there which is just sitting. This is baked for MLX community by MLX community for MLX. So this is specific to MLX, and just a for loop, so you can get chunks of audio which is waveform eventually, so you can stream the audio. That's mostly it. So I was trying to build something from that, so I used a model for TTS, which is Kokoro, which I mentioned earlier, which is a very fast multilingual TTS. Now this can also speak in Japanese, which is amazing for just 82 million parameters. This has 54 voices and 8 languages and has like many preset of voices. Like one is AF heart. AF heart is just like, imagine it as an accent. So a girl's voice with some accent, and probably have like multiple type of voices, which could be male, which could be a Japanese voice, could be some girl with a British accent or anything. It also has language code, which is very interesting. So this is how the pronunciation engine picks up what to use. Kokoro itself has, I'm assuming, 3 or 4 pronunciation engines, and you can just pick up the language code which you want and it would pronunciate accordingly. Now going deep into TTS model, this is just a simple way of how TTS actually work. So TTS is just text and then it goes, so this is the architecture of Kokoro, which is a TTS model. So you have a text, you set a pronunciation of that text, which could be like here I mentioned down there cat, which is KAT. Like this is how pronunciation comes when you're using a TTS model. This is definitely the architecture of Kokoro. Different models work differently. Then that sound creates a spectrogram, and then spectrogram is sent to a vocoder, which is just outputting waveform, which is just the audio of it. So this is basically how Kokoro works. In simple words, it is words become sound, sound becomes a waveform. Some variable you can toggle with is temperature, block size, prompt category, which is as simple as the block size is the chunk size of the waveform you want to get. Temperature is for how models work, and prompt category can be like, is it a conversational model? Like, are you using it for conversational? Are you using it for storytelling? Something like that. When I was trying to build something with it, so I wanted to build a voice assistant. So obviously for that, you need TTS, STT and many things. So diving into a STT model, which is Whisper. Now this was also running locally at my device. This is a distilled version of that, which is made by OpenAI. It supports 99 plus languages, and I'll quickly explain ki distill kya hota hai. Distill is like, imagine you have a parent model which is very big and you have a small model. So whatever the bigger model is outputting, you try to train the small model according to that कि इसको replicate करो जितना हो सकता है. तो eventually this is very small, but this performs as the big model. This is what a distill model is. So Whisper architecture is just getting the audio, encoding it, processing it, and just decoding text out of that. So the thing is, with MLX audio, it's not just about TTS or STT. You can probably do voice cloning, you can do diarization, anything, and it is as simple as the code I showed you earlier. Just load the model and generate, which is a function. So this library makes running voice models locally very easy and probably very fast, because the models are such slow and it is optimized for voice. There is also one library for video as well, but this is for audio. And you can also, this supports quantizing models. Here what is happening, I'll explain like in short. So you are using the MLX-Audio.convert, the thing you were telling about converting quantizing models. Select the model name and give it a path, and just select what bit you want to quantize it. Imagine you have a M1 Pro, you have limited memory, or you have a MacBook Air. So obviously you want to make the model small so it can run on your Mac. So you can quantize it by this. It will become smaller, it will probably lose some of its intelligence, but it will be very negligible and it will run way faster on your Mac. So what I built, I took audio from my Mac, give it to Whisper, which will basically do STT, speech to text. Then for brain, I needed something which is a Quen model, and whatever that brain outputted as text, I took that and it was converted into speech. So it is basically STT, brain, TTS. About the models I used were Whisper, Quen 3B, Kokoro. And interestingly, the memory usage is only 3.9 GB, which works on my Mac. And at resting, it was 3.9 GB. While it was talking, it was 4.2 GB out of my 24 GB of RAM, which is very good for me, and it is like I don't feel lag or something, in at least in my Mac. I can show a quick demo. I have terminal running, I guess. So it's loading all the three models, and let's see if the audio is here. Hey, hello, do you know about MLX Audio?
Yeah, MLX-Audio is pretty neat. It's a framework that lets you use Metal for audio processing.
Now, this thing is running locally.
Especially good for machine learning.
I'll just stop it for a while. I'm assuming this is slow because of this. Just give me a second. I hope you can hear my MacBook speakers, and let's try now. Hello, do you know about what are your views on MLX in general?
Sure, MLX engineering is all
Now
about
this is
leveraging
fast.
Apple's Metal
It was
framework
feeling a bit
for
laggy there.
efficient and high-performance computing on Apple Silicon.
Now imagine most of you guys would use Whisper Flow, I am imagining. I can build that locally and just use it, and it would just exist in my memory and probably consume more memory than Whisper Flow, I don't know. But I would use it for free, right? So the limitations are probably nothing on my Mac. I can build actually anything I want. So I gave it memory as well, but I'll build this into something more big eventually, where I just have a model locally which I can use anytime without internet, and it just works out of the box. One interesting thing. So the model I told you about, the TTS model Kokoro, it had 54 languages and stuff, right? So let's try translation in Japanese, which will work locally. Hey, I am here for MLX India and doing a meetup in Delhi.
Tatson zehşitin. Israellu ein intraktion, especiallu on plesilicho. Betio, reointo.
I don't know how accurate it is, definitely, but yes, imagine a translation model running on your Mac or probably on your iPhone, which runs locally. You don't have to get any internet connection, and you can make it however you want. You can cater it to your use case and build anything with MLX voice in general. That was it. If you guys have any question, I'm up for it.